Example 3. A textbook age follows a normal distribution. How much does the age of a textbook vary by in the bookstore? A sample of 5 books has ages of 5, 7, 5, 8, and 5 years, we'll assume. Create a 90% confidence interval with 1 digit after the decimal. Okay, so we know we have a normally distributed population, which we need. We don't actually see that our confidence interval is for a standard deviation. It just says to create a 90% confidence interval. But the question is, how much does the age of a textbook vary by? Whoops, cross that out. And so vary being the key word, and standard deviation is a form of variance, and vary here means to vary. I guess that's kind of redundant. Okay, so if I'm going to make a confidence interval about a standard deviation, then first I need to have a sample standard deviation, which I don't have, but because I have the ages of some textbooks, I can find that. So first I need to find S, my sample standard deviation, and hopefully you can just go ahead and enter those numbers into your calculator and push the button for a sample standard deviation, because that's what we have, is a sample. And when I did that, I found S was 1.414213, etc. And I went off the edge of my calculator. So if you can't enter that whole long number, remember you want to go at least 5 places to the right of the decimal, so the second one after the decimal, which will stay at 1. It won't round up because it only has a 3 after it. And we know that N is 5. It told us we had 5 numbers, and our count of data we entered is 5. So if I have a 90% confidence interval, alpha is 10% or 0.10, and alpha over 2 is 0.05. And since for chi-squared left, I'll need the complement of that. Well, I wrote that backwards. That shouldn't be 0.05, gave me 0.95. Okay, it's fixed. So for chi-squared right, row 4, column 0.05, and I find 9.488. See if you can find chi-squared left on your own. Did you go to row 4, column 0.95, and find 0.711? Okay, so I'm taking the giant square root of n minus 1 times s squared divided by my chi-squared right, and hopefully my population standard deviation is between that number and the square root of n minus 1 times s divided by chi-squared left. I enter that into my calculator. And if I hadn't taken the square root yet, I might be a little worried, because if you notice these two numbers, that S, my sample standard deviation, is actually in that range. But hopefully I knew I needed to take a square root still, and I get 0.918, etc. to 3.54, etc. And yes, my sample standard deviation is in there. So I'm ready to go ahead and answer the question. 0.9 to 3.4, since I'm only going 1 digit after the decimal, is not the average age of the textbooks, but about how much they're off by. And if you look at these numbers, they all do seem to be within about 1 to 3.5 years of each other.